And welcome back. It's the 1st of August, high five a day, and let's just go straight to the first one. Now, what do we have? So Kiara takes a box of counters, takes out 40 and 7 of them are red. Okay, so a couple of ways of approaching this question. So first of all, there are 1,200 counters in total, and if I take out 40, 740 of them are red. So again, were red. And then it says use this information. Now the key word here is the word estimate, because I'm going to assume that if I take a random selection of counters from this box, 740 of them will be red. So if there's 1,200 in total, that means therefore that must be how many red I have in total. Now this could be a non-calculated question, couldn't it? Because if I write it like this, which of course is the same thing, I will notice I can cancel my zeros, or in other words, divide top and bottom by 10. I can cancel or divide both sides by 4, top and bottom by 4, which gives me 30, and 7 times 30 is 210, and that is my answer. Next question. Simplify fully. Now the word fully is important here because fully means I might have to do a couple of steps. You need to be careful. Sometimes it's a bit of a hint. Almost always these are factorising questions. So I'm going to factorise the top to x times x plus 8. I'm going to factorise the bottom. Now this is one of these you need to get used to recognising. This is difference of two squares. I can square root this, I can square root that. There's a minus in the middle, so it is literally a difference of two squares. What I can then notice if I have a factor of x plus 8 on the top, x plus 8 on the bottom, and that's going to give me an overall answer of x divided by x minus 8 on the bottom. There we go, question done. Next question. Is it possible to fit a thin straight rod that is exactly into the box? Okay, I like this question. This question is basically saying in a very clever way, what is the length that gets me from the bottom corner to the opposite corner? If the length is shorter than the length from the top corner to the bottom corner, that rod must fit. Again, it's basically saying what is that length? I'm going to call it B and A, then you know what I'm doing. What is the length from A to B? Now you may not have come across it yet, but there is something called 3D Pythagoras. So instead of working out the bottom triangle and then adding on the top triangle, I can do this in one go. I can say it's 10 squared plus 3 squared plus 5 squared. Now, if you do it in two lots, you will have done that calculation, square root and then squared again. All I'm doing is doing that in one step. So again, you can do this non-calculator, I guess. That's going to be 10 squared plus 3 squared is 109 plus 25, which is going to be 134. This is probably going to be a calculator question because I need to do the comparison. So if I do the square root of 134, well, the calculator tells me that's 11.575836.9, which I'm going to approximate is 11.6. Then a clear statement. So as 11.6, need to answer the question, is greater than 11.5, yes, there's my answer. Rod, is it a rod? Yes, it is. Rod will fit. And there we go, question done. Not too bad. Notice I've gave a conclusion with reasoning. You will not get the answer if you just write yes. Next question. A, B, C, D, E, F is a regular hexagon. Now, regular hexagons are really popular in what is a vector question. And that is because you straight away know that hexagons are built of equilateral triangles, which means that these sides here are the same vector. And similarly, because it is a regular hexagon built of equilateral triangles, these here are also the same vector, crucially going in the same direction. So I'm going to put arrows on so I don't make a silly error. So A goes in this direction and my B's go in that direction. Let's actually now read the question. So the question says, what is the vector to get from B to A? Now I can only go down paths where I know where that vector is. So the way I'm going to do that is I'm going to go from B to O, and then I'm going to go from O to A. And B to O is negative B because I'm going against the arrow, and then O to A is positive A because I'm going in line with the arrow. In other words, it's minus B plus A, or equally acceptable A minus B. Crucially, I'm going to do a different color again. I now know to get from B to A, so in this direction, I know that vector is A minus B, which means I know this is A minus B, and I know this is A minus B, and I know this is A minus B as well. Let's read the next one. Find in terms of A and B the vector of F to C. Well, actually, I've kind of just done it for me because F to C is minus the thing I've just done, and it's two lots. So it's this one here, and then it's this one here. So it's going to be minus two lots. I'm going against the arrow of A minus B. That, by the way, would be fine, but let's expand it, which is going to give me minus 2A plus 2B. All various versions where I've expanded it or factorized it are also fine. Either way, question done. Next one. Find in terms of A and B the vector E to D. Where's E and where's D? Oh, actually, it's slightly easier than the one I've just done. Same direction we've just done. There's only one of them, so therefore it's just going to be b minus a. And that is it. Today done. Not too bad today at all today. Nice mix of questions as ever. Question statement you'll hear me say a lot. If this is the first video you've watched, do like and subscribe. Really helps the channel grow. The algorithm, etc. does matter. Either way, see you tomorrow for the next one. Thanks all.